Welcome back to another video, grade 12. In this video, we will be taking a look at Newton's second law of motion in terms of momentum, impulse, and the impulse-momentum theorem. So Newton's second law of motion in terms of momentum says that the net, or we can call it the resultant force, acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. In symbol form, we have the net force, which is F net, measured in newtons, is equal to change in momentum divided by change in time. Change in momentum is still measured in kilograms per meter per second, and we can expand it so that it is equal to final momentum minus initial momentum. In the previous video, you may remember I showed you that this can be expanded further so that we have m, the mass of the object, v final minus v initial, and in this case we are still dividing by time. So this is how we can calculate the net force by making use of an object's change in momentum. We therefore can come to the conclusion that if an object's momentum changes, in other words, if its speed changes, then it means that a net force is acting on the object. Remember that net force is a vector quantity, and so is change in momentum. So when we use this formula, we must, number one, remember to choose one direction as positive, and we must also remember to provide our answers with the correct direction. We say here the change in momentum is always in the direction of the net force. Please, grade 12s, do not forget direction when performing your calculations. We can define impulse as the product of the resultant or net force acting on an object and the time that the net force acts on the object. We write down impulse is equal to the net force multiplied by change in time. Net force is still measured in newtons, and time is of course still measured in seconds. Therefore, grade 12s, we say that impulse is measured in Newton seconds. Very important, this is not newtons per second, so there is no negative on the seconds. Instead, it is simply newtons multiplied by seconds. We are not dividing by seconds. Soon you're going to learn, using the impulse-momentum theorem, that we can also measure impulse in kilograms per meter per second, because there is a relationship between impulse and momentum. This relationship is called the impulse-momentum theorem, and in symbol form it says the net force multiplied by the change in time, this of course is the impulse, is equal to an object's change in momentum. This is the impulse-momentum theorem, and you can find it on your formula sheet. Please don't forget that the change in momentum is equal to the final momentum minus the initial momentum, and we can say this is equal to mass v final minus v initial. So either version of this, you're of course going to start off by writing down this formula as it appears on your formula sheet, but you can expand the right-hand side of the formula. Let's now look at an example. This example reads, a car is traveling eastwards along a straight road. Notice that they have already given us the type of direction to use. We're making use of compass directions. And remember that the opposite direction to eastwards is westwards, or we can say towards the west. They now say the driver sees an obstacle across the road and then applies the brakes. Once applied, the brakes allow the car to slow down. Unfortunately, this is not sufficient and the car crashes into the obstacle. The car hits the obstacle with a speed of 4,674 meters per second, and it takes 0,2 seconds for the car to come to a stop. The mass of the car is 1,100 kilograms. Now, before we move on to the questions, let's try to understand what useful information has been provided to us. Firstly, we know the types of directions we're dealing with. We know that the initial speed is going to equal to 4,674 meters per second. The time taken for the car, or the time during which the car collides with the object and comes to a stop, is 0,2 seconds. Since the car comes to a stop, the final velocity or the final speed is going to be 0 meters per second. Fortunately, since this car is traveling in a straight line towards the east, the speed is equal in magnitude to the velocity. So these values we can take as the velocity as well, remembering that velocity has direction, of course. And lastly, we have the mass. Now, it's very important that we choose a direction as positive. How about we choose towards the east as the positive direction? This means that towards the west will be negative. The first question says define the term impulse. I'm going to leave that up to you and move on to the next question that says calculate the change in momentum that the car experiences. To calculate change in momentum, we're going to use the formula that I've written down so many times. It is the mass multiplied by the final velocity minus the initial velocity. That is going to equal to 0 minus the initial velocity is going to be positive 4674. Now there is a negative in front of this value, but that is because of the formula. Don't get confused. When we plug this into our calculators, we find out that the change in momentum is negative 5141,4 kilograms per meter per second. But we can't leave our answer as negative. We need to interpret this negative value. Since we chose east to be positive, it means that this means 4141,4 kilograms per meter per second west is the object's change in momentum. This is out of 4 marks. You will probably obtain 1 mark for your formula, 1 mark for substituting, 1 mark for the magnitude and SI unit, and 1 mark for the correct direction. So grade 12s, please do not forget your direction. The next question says, calculate the resultant force, that is F net of course, on the car during the collision. So over here, we're either going to have to make use of Newton's second law in terms of momentum, or we can simply make use of the impulse momentum theorem. The impulse momentum theorem says that the net force multiplied by change in time, this is the impulse, is equal to the object's change in momentum. We are looking for the net force. Now the reason why I've chosen this version, the impulse momentum theorem, is because it is provided on your formula sheet instead of Newton's second law in terms of momentum. But you can find Newton's second law in terms of momentum by simply dividing by the change in time. Okay, so let's substitute directly into this formula exactly what we know. We know the time is 0,2. The change in momentum we just calculated. Now grade 12s, the change in momentum is negative. So please remember to substitute it into the formula with the negative value, because change in momentum is a vector. So when you make the substitution, you must plug it in with its direction. Dividing both sides by 0,2, we find that the net force is negative 25707. And remember, we now need to interpret that negative, so it's positive 25707, and this will be Newton since it is net force. The negative means in the opposite direction to east, which we chose as positive, and therefore the net force is towards the west. Again, we see what I showed you in the previous video, and that is, or maybe it was in this video, my apologies for the confusion, but we see that the net force acts in the same direction as the object's change in momentum, because it is the net force that is responsible for the object's change in momentum. This question is out of 3 marks, so we have 1 mark for the formula, 1 mark for substituting, and 1 mark for the final answer with the direction.